Alrighty, this is going to be a short little video, but it's got a pretty key theorem in it. It's called the opposite parts theorem in a lot of books. Your book may or may not call it that, but I'm going to call it the opposite parts theorem, and it refers to a triangle. And it's this basic idea. Draw yourself a nice triangle, but make it so there's a really long side and a really short side, something like that. And let's connect this baby up. All right, that's pretty good. So here's the deal. When you go for the largest angle in this triangle, where's the biggest angle in this triangle? And if you're looking at this one right here, mine's obtuse, so this is clearly the biggest. This is the largest angle right here, and I'm going to label this angle L for largest angle. Where do you see the largest side of the triangle? The largest side I asked you to draw was this first one, the one I drew right here. So this side right here is the longest side. And that's going to be true of any triangle. What I'm seeing is that the biggest angle and the longest side are opposite each other in the triangle. So if you kind of point from that angle across the triangle to that side, that's what you're going to see. And that makes some sense, because if this is the biggest angle, it's opened the widest, then to connect up the ends of that angle, you're making the triangle, that's going to be your longest side. So the largest angle is opposite the largest or the longest side. All right, well, what about the smallest angle? The smallest angle in this triangle is this one right here for mine. And that little baby angle right there isn't opened up very wide. So what's going to be true of the side across from it? If it's not opened up very wide, then this side across from it is not going to be very long. So this is actually going to be the smallest. And I don't want to go off the screen there, but that's the smallest angle right here. So I'm going to call this S for small. And I find it across the triangle or opposite the smallest side. So the smallest angle is opposite the shortest side. And then there's that third one. We don't want to leave him out. So this is the middle, the mid-size angle here. And guess what? This is the mid-size length across from it. So the mid-size angle is opposite the mid-size length. And that's a really nice thing to know about triangles. Just ask my pre-calculus students. They use that idea all the time as a check in their problems. Let's look at an example. In these, we're going to name the longest side and the shortest side in each triangle. So all we know is information about the angles, but that's all we really need to know. Let's look for the longest side by just finding the biggest or the largest angle, and that's this angle right here. The 69 degrees is the biggest angle, so it's opened up the widest. I'm going to find the longest side across from it. So right here, this is going to be FG. FG is the longest side. We're also asked to find the shortest side. Well, I'm going to look for the smallest angle. The smallest angle is this 54-degree angle, and that means it's right across from the smallest side in this triangle, so HF is the shortest side. That's all there is to it. Now, what if there's not a largest angle? Like in this one, it's a tie. 70 and 70 are in a tie for the biggest angle. Well, that means that there are two sides the same, and you might remember this. This was our isosceles triangle theorem. The two angles that are equal are going to be across from equal sides. So if we have a longest, it's going to be a tie. Let's say it's either SQ. Well, let's not say either, it's both of them. They're tied. So SQ as well as this one across here, RQ. So they're in a tie for longest side. What's our shortest side? Well, our smallest angle is the 40, so it's across from our smallest side. SR is the shortest side. That's how you do it. All right, now in this one, we're going to put the angles in order from the smallest to the largest. And sure enough, all they told us was sides. So we want to go small to large. Let's read those directions carefully. Small to large. So where's my smallest side? My smallest side is the 14. I'm going to find my smallest angle directly opposite it. So angle Y is our smallest angle. Next is the middle one. The middle one is the 15. So it's directly opposite the mid-size angle. So that's going to be angle W is next. And my largest. My largest one is this 19 length. So my largest side is right across from it right here. Angle X is the largest. And that's the opposite parts theorem. I hope you find it pretty easy.